Hello and welcome back. Firstly, I'd like to say Happy New Year to everybody, and I hope that your holiday season is going well and everyone is keeping safe. In my last video, just before Christmas, I mentioned that I bought this lathe. It's a wood lathe, a little bit different to what I normally do. And I mentioned in that video that I need to do a bit of work on this lathe to get it all up and running. So I'm going to start a little series of videos here on the jobs that I was going to do. These tasks include pulling apart the headstock and the tailstock and just checking them all out. There's bolts missing out of the bottom here. The bearings are a bit grindy. It's a little bit sloppy down here in the tailstock. So there's a few things that need to be looked at in those areas. Also wanted to change this pulley system to a CVT. So instead of having like 3 pulley grooves here and 3 pulley grooves there and you change the belt, you basically have 1 pulley on each, the lathe and the motor, and that pulley is a special pulley which is split so that it can be widened apart and made narrow again through mechanical mechanism, and that way you can change the ratios of resolution. So in one configuration you might have it so the motor turns once and this spindle turns 2 times. In another configuration it might be the opposite, where the motor spins once and the spindle here only turns half a turn. So that's going to be probably a bit of a challenging project, but I've got some good ideas around it and I think that'll work out okay. The other thing I wanted to do is put a tachometer on it so that I can know exactly what revolutions we're doing. It saves using one of those, laser tachometers where you stick a silver bit of tape or something somewhere and you shine the laser at it. But anyway, in today's video we're going to do the first job, which is to make a stand for this lathe here. And I'm going to make the stand out of metal. In fact, it's going to be made out of this metal here. So this is a 60mm by 80mm rectangle, and I have quite a lot of this. I bought it quite cheap. It wasn't in full length, so it was only like about 1500 or 1.5 meters long each length. But the lathe beard here is only 1200 long, so it's plenty long enough to make the lathe stand. So I'll put 2 pieces this way, standing up. That should give me my width across the lathe bed. And then I'll have some pieces going like this for the legs. Once the stand is complete, I can bolt the lathe bed to the stand, and that gets it off my bench here, and I can work on it in other parts of the workshop here. Now for the legs, I want to have some adjusters down there as well, so that if the lathe is, in the garage and the floor's a little uneven, I can just turn the adjusters and level it all up. So let's get started. The first thing I wanted to do was take some measurements of the lathe, how long it is, the width, and particularly where these bolt holes are. These are the 2 bits of steel that will become the top of the lathe stand. They will be orientated the other way with the wider side flat down on the table. These are mounting blocks. They're 16mm thick. They will be welded to that top part of the lathe stand, and they will have threads in them for the lathe to bolt onto them. The lathe came with a 3rd horsepower motor, and this is the 1/2 horsepower motor that I found. The original motor used to be mounted on the side here like this, but I think that's not going to work with the speed range that I want, so I'm going to have to mount the motor below, because I think I'm going to need a jack shaft in the middle with extra pulleys on it. Now measuring out the bits of steel for the top part of the lathe stand. Those get cut off in the bandsaw. I clean them up with a wire wheel. They're initially tacked together and then they're welded with some longer welds. This is a 3mm end cap, that's the tailstock end. And then this is the headstock end, which is 10mm. I use 10mm because I suspect that I will be bolting or welding something to this end of the lathe stand. So I'm orientating the lathe on the top part here and working out where to drill the holes. I drill those holes in the mill that take a M10 thread. And those holes are then tapped out. Then I bolt the lathe onto those blocks and we're ready to work out where this is welded to the top part of the stand. So I've got the top part of the stand complete, and I've made up these little pedestal bits for the mounting here, and pretty much up to the stage where these get welded onto the top part, and then that's how the lathe will bolt onto the stand. So the question is all about the position now, going across this way. It's obvious that it needs to be in the center, but where do we put it this way? And I've had a long and hard think about this, because sort of working out the ratios for the pulleys and the motor, even with the Reeves drive, I'm not going to get the range of RPMs that I need. So I'm going to probably have to have some sort of jack shaft in the middle and have the Reeve drive on that here. So there will be a pulley here, the Reeve drive, and then of course down to the motor down below. And when I made this top part of the stand, I actually put a 10mm plate on the end here because I knew that I was going to be needing to either weld or bolt something solid onto this. The other thing I want to do is I want to cover in the pulleys as well and the belts, you know, so it's safe and little fingers can't get in there. And to do that, I think the best option is to put a plate right up the side here, and maybe some sort of part at the top and down the back. But the issue is this cast iron bed here actually tapers out a little bit this way at the bottom here. So I've got this part here which is straight up and down, pretty much in line with this piece here, but we're kind of about 5mm too far this way on this part here. Now, as I mentioned, I had a long hard think about this and what different ways on how to overcome the problem. The first option I thought of was move the whole bed forward, and then slide the headstock back, you know, about 5mm or so. But the problem is this headstock fits inside the gap in the middle, and there's only a little bit at the end here that fits in the gap. So once you come forward past the end here, it comes out, and then the alignment is only just relying on the front. And of course you'd have to slot out the holes inside the bed so that it can be still bolted down and stuff like that. The other option was to maybe put a spacer plate in here, 10 or 12 or even 20mm spacer plate, and that gets bolted to the headstock and then gets bolted to here, and then it can be slid back that way so that we get this face in line with this, and this bed would be moved more forward this way. Of course, if I do that with the headstock, then I have to machine up the same thickness spacer plate for the tailstock to keep all that aligned, so that was going to turn into a bit of a nightmare probably. The last option was to machine off the 5mm here. So this is flush. I mean, I've had this off and it's not aligned. It's a little bit crooked at the moment, but it's pretty much straight up and down here. The start of the bed is straight up and down as well, and then it sort of tapers out a bit. And that ribbing at the bottom there it's around about 10 millimeters thick, so it's kind of quite thick. The plan now is to just mill a bit off the front here, 5 millimeters, or probably till I get down to this area here, and then bring it all the way back, square it all up, and then weld the sort of pedestal feet to the top frame here. And if I do that and have it all flat at the front here, then I'll be able to put a nice big plate up here and be easier for me to mount jack shafts on here and to close it all in and to do everything that I need to do. Just using a dial indicator to make sure that this is square to the bed. And then I'd use a short end mill initially to take down the side. And then this is the longest end mill I have, which is just long enough to do the job. It looks really good and square now. I've put the lathe back onto the top part of the stand and that looks square on there as well. So now I'm clamping down the lathe onto the top part of the stand and welding these spacer blocks onto the top part of the stand. Cleaning up the welds. And bolting down the lathe to the top part of the stand. I have it up here on sawhorses and I'm working out the height for the next part, which will be making the legs. I set the bandsaw up on an angle so all the cuts are the same. And start cutting the legs. These are all cut from large pieces. And then I come back later and trim the ends off to the right length and the right angle. They are all cleaned up with a wire wheel. I've set that up on the welding table and I've made a cross brace there as well. I draw an outline of this setup so that I can make the second one to exactly the same shape. I initially tack it all together and then weld it solid. And those welds are cleaned up on the front and back surfaces. I put the second A-frame on top of the first one and that lines up absolutely perfectly. These are some 10mm pieces that were for another project and I didn't use. So they'll be perfect for the feet for the legs. I just have to drill them out and tap a M20 thread into them. Those pieces are welded onto the bottom of the legs. And of course we clean it all up again. Now the top of the A-frames weren't flat, so I've set it up in the mill and I'm just taking it down until it's all cleaned up. There are some 10mm plates that fit onto the ends of those A-frames and I'm just rounding the corners off here so they fit nicely. Now there will be some threads cut into these plates and that's how the top part is fixed to these legs. They're tacked and fully welded on. And then of course all cleaned up with the flap disc again. I welded on a bit of 3mm plate to support the mounting bolts. Those mounting holes are drilled in the drill press and then I come back and transfer those holes onto the legs. The legs are then tapped out to M12. I come through later with a 12mm drill bit to open the holes out for the M12 bolts. I found these round pieces in the scrap bin and they will work really good for the adjustable feet. There's one good face and there's the other face needed cleaning up. And then I cut them in half here, and that will give me 4 pieces. Here's some M20 all thread. I'm just marking out 4 pieces at 100mm, and we cut them off. Now I put it back in the lathe and we clean up the rough sawn part. We're just putting a recess here, and that's so I can press the all thread into the hole. I drill the hole out to 19.5mm and then I press in the all thread. And then that gets welded on the end there. And it doesn't run that true, so I give it a clean up on the back and across the surface and on the face as well. Give it a bit of a chamfer there on the edges. And I didn't show it on video, but I did use the flat disc to scallop out the centre of those feet so that the outsides of those feet touch the ground. And this is the fun part, assembly. So pretty much just 2 bolts on each end to hold on those legs. Drop the lathe on the top there. And there's 4 bolts that hold that lathe on. And then I go into the garage for about 2 hours and do a bit of cleanup so I can make some room for it. There she is, all assembled, and she is very solid. I've adjusted the feet down the bottom for the uneven concrete here, and it's pretty solid. It's pretty heavy too. I was quite surprised. I was going to put a plug in here so that the legs can be filled up with sand if it starts, dancing around the garage floor, for not being heavy enough, but we'll come to that a little bit later on. So there's a couple of things that are still to do on this. One, as you can see, I haven't painted it. I'm going to be doing a lot of work around here with the Reeves drive and possibly welding plates on the side here and stuff, so I think I'll do all the painting right at the end. The other thing is, a lot of stands I see like this on the internet have a piece of wood or something along the bottom where those cross braces are. I may put that in, I'm not sure yet, so it's something to consider later on, I guess. Again, it just depends if there's enough weight in it to stop it moving around. I see a lot of people on the internet have boards down the bottom and they put bags of cement or sand on them to keep their lathes from dancing around there. And the other thing is, I haven't made a bracket up for the motor, and the reason for that is I'm not really sure where the motor's going to go at this point. So that all depends on the Reeves drive in the middle, and then the motor, and then it needs to have belts and be able to be tensioned and stuff like that. So that motor mount is going to be done when I do this Reeves drive. So in the next video I'll work on the Reeves drives and I'll work on the pulleys. I'm not sure if I have to make up new pulleys for here and for the motor. These are just the standard V-belt pulleys. I presume there's a certain degree angle in here, and maybe it's different to what you have on a Reeves drive. So I have to do a little bit of research before I start on this, just to see what I need to do. I have no problem casting up some aluminium and turning a pulley, and of course I'm going to have to make the Reeves drives pulley as well, so there's a little bit of work involved in that. If you like my videos, click on the subscribe button and click on the bell button if you want to be notified when I release new videos. As per always, thanks for watching.